So we're going to look at these transformations a little more closely, or a little more neatly than in the first video I made. So we'll look at numbers 1 through 3. On the first one, we've got that quadratic, y equals negative x plus 3 squared minus 2, right here. So we'll go and let me show you how I think through this. Now I used Desmond to help me out. So what I did is I graphed the parent function. Here's you can see the equation here, y equals x squared, and that's this red graph through here. That's just the parent function, and at this point I would expect that you're pretty competent with that. And then I said, okay, well, what happens when I put a negative out in front? Well, that reflects it over the x-axis, giving me this blue graph. And then I needed to shift it. So the plus 3 actually shifts it to the left 3, so and then the minus 2 shifts it down. So that vertex, we have the same exact shape. So all of these we would call our rigid transformations. We haven't affected the shape of the graph, we've just moved it around. We've reflected it and then we moved it. And so this new graph, the final answer is this green curve right through here. The next one deals with absolute values, and so you'll notice we started with the absolute value, just let me try that again. We started with just the absolute value of x, and that's this purple one, that it's got a slope of 1. Notice I'm going over 1, up 1, over 1, up 1. That's a little confusing in that space, but notice I start at 0, 0, and I make it through 5, 5. So that's a slope of 1, and likewise a slope of negative 1. So then the next thing I graphed is I said, okay, well, what happens when I put a 3 inside with that? It stretches it vertically, so it kind of pulls it apart this way. It pulls it up, and it gives us a slope of 3. So I went up 1, 2, 3, and then over 1, up 1, 2, 3, and then over 1, like that, as I travel along this line. Then the next thing I did is I wanted to shift, this is going to shift it to the right too. So I took that yellow graph and I moved it to the right too, and this one right here is our final answer. Keep in mind, I could have said that this is y is equal to the absolute value of 3x minus 6. That's just distributing that 3 through right here. When I do that, it gives us the equation as they wrote it on the worksheet. But be careful that when you see this right here, you don't think that's a shift of 6. It's a shift of 2. You need to always factor it out to see what the shift is. The next one involved square roots. So I started with the parent function. Then I reflected it. Now notice when I put it under the radical sign, that changes the domain. So instead of having positive values here and 0, I now have 0 and the negative values because I need a negative negative so I can take the square root of a positive. So parent function, the reflection over the y-axis. Then I had a vertical stretch. So instead of having the point negative 1, okay, let me try that again. Instead of having the point negative 1, 1, I now have the point negative 1, 3. Instead of having the point negative 1, 2, 3, 4, 2. Do you see how the square root of 4 is 2? So the square root of negative 4 is still 2. Instead of negative 4, 2, I now have negative 4, 2 times 3 is 6. And sure enough, that point is up at 6. So then I went from the red to the blue to the green, and then they said, nope, shift it over. So we needed to shift it to the right 4 and down 2, and that's where we get this graph right here. I tried to take a screen capture holding down the button at this starting point, but it didn't work. Anyway, whatever. So that is the point 4, negative 2 right here, and that's kind of it helps us know the domain and range of this graph. So that the domain, and they didn't ask this, but here we go, goes from negative infinity to positive 4. It does include positive 4. The range starts at negative 2 and then goes up. So it includes negative 2 and then it goes to infinity. And this purple graph through here is the final answer to that problem.